Hey everybody, we are going to be learning about the Pythagorean theorem today. So the Pythagorean is used to find the missing sides of a right triangle. So the sides that are represented as A and B are called the legs, and C is referred to as the hypotenuse. And the equation is a squared plus b squared is equal to c squared. So we're going to use that equation to solve for the missing sides of a triangle. So if you see here, the hypotenuse is always across from that 90-degree angle. So 8 squared plus 13 squared is equal to x squared. It doesn't matter what you plug a and b in for, just as long as they're on the one side of the equation being added together. So if we add 18 squared plus 13 squared, we get 233, and we are going to take the square root of both sides. So x is equal to 15.3. I always round to 1 decimal point, so that's what it's going to be on any of our assessments. For number 2, again, we're solving for x, which is the hypotenuse. So 27 squared plus 22 squared is equal to x squared. 27 squared plus 22 squared is 1213. Take the square root. So x is equal to 34.8. This problem's set up a little bit different. We are trying to solve for what the hypotenuse is. So 7 squared plus x squared is equal to 9 squared. If I write this in terms of x squared, in my calculator I'm doing 9 squared minus 7 squared. So x squared is equal to 32. Take the square root of 32 and you get x is equal to 5.7. All right, the next problem, 30.5 squared is equal to 19.1 squared plus x squared. And now it doesn't matter how you write the equation, just as, like I said, as long as you're keeping everything the same. So I just wanted to show you it in a different way. So for here, I'm doing 30.5 squared minus 19.1 squared is equal to x squared. So we get that, and we take the square root, and we get x is equal to 30. Oh, I did something wrong. I'm sorry. That is not correct. I accidentally pressed the plus sign when I did this, so I actually have to subtract it. There we go. That looks a lot better. Now we take the square root of both sides. And we get 23.8. So number 5 looks a little bit different, but all we have to do is remember back to like previous units of what we did. This is an isosceles triangle. So this line that goes from one vertex to the other and is perpendicular is called the altitude. So that cuts the base into 2 equal parts. So we're going to focus on that red triangle there. So 24 squared is equal to x squared plus 11 squared. So we get x squared is equal to 455. Take the square root of it, and we get x is equal to 21.3. For this problem, we need to create a line that makes this a rectangle. And if we remember back to the last unit, rectangles, the opposite sides are equal. So if this is 5, 18 minus 5 is 13. So in this red triangle here, we could solve for x. Okay. And this problem, we need to have, break this into A and B. So in this red triangle here, we have 14 squared is equal to 12 squared plus A squared. And then in this blue triangle here, remembering that this is 12, we need to do 29 squared is equal to 12 squared plus B squared. And then to solve for x, we're just going to add these two together. We get 33.6. Over here, we need to first use this bottom triangle so that we can then find that missing side of the top triangle. So we'll just call this as, we'll call it y. So 25 squared is equal to x squared plus, y squared plus 10 squared. And then we can use 22.9 for the top triangle. And that is our answer. So we have to add some information here. If this is 26, this down here is also 26. And then if you do 26 minus 40, we get 14 divided by 2, which is 7. So that means both of those sides are 7. So what we need to do is we first need to, oh, and I also have 20 over here because they're the same. Now I can use that red triangle. And there we go. Now we're going to get to word problems. So 10, 11, 12, 13 have to deal with word problems. The hardest part of this is actually just trying to determine how you set this up. So a roofer leaned a 16-foot ladder against a house. If the base of the ladder is 5 feet from the house, how high does the ladder reach? So ladder, that's how far away from the house. Trying to find how high up the house. So now we can set an equation. Kurt is building a rectangular deck. The deck is 10 by 23. What is the length of the diagonal? So we would have x squared is equal to 10 squared plus 23 squared. Ashley jogged 3.4 miles east and then 5.7 miles south. How far did Ashley jog? How far is Ashley from her starting point? So this is a right triangle problem. So 33.4 plus 5.7 squared is equal to x squared. So we have 6.6 miles. And a 31-foot wire is attached from the top of a 25-foot pole. How far is the base of the pole to where the wire meets? So we have 31 squared is equal to 25 squared plus x squared. We get 336 is equal to x squared. Hold on. And then we get x is equal to 18.3 feet. So that's how far it is. Hope this helped. Now you know the Pythagorean.